Okay, good afternoon, everyone, and welcome to our last but not least Facebook Live of our Digital Discovery Festival, part of British Science Week. We are super excited to be here today, this afternoon, with Professor David Pyle, who's a volcanologist. So obviously we're talking all things volcanoes, and excitingly, David's been behind this Volcanoes exhibition. So we thought we'd just go on a little tour. So you just want to talk us through the tour? Let's go in.
So we're in the Weston Library, the Bodleian Libraries, and I've curated an exhibition. There are 84 objects in here. Almost all of them are from the Bodleian Library collections themselves. We're going to start off by going into the room, which is quite dark, and we're going to see a fragment of papyrus which was scorched during the 79 AD eruption of Vesuvius.
Let's go have a look. Okay, so it's going to be dark, but keep with us, Okay then. Okay, what are we looking at? Oh.
So the theme of the exhibition is volcanoes, and it's telling the story of people's encounters with volcanoes, visiting volcanoes through the centuries. And this is the most spectacular object in the exhibition for me. It's a 2,000-year-old fragment of papyrus. It's a scroll that was written on. It was from a library in a town called Herculaneum, and this was buried by pyroclastic debris during the 79 AD eruption of Vesuvius. And the debris that buried the library was so hot that it's turned the piece of papyrus into charcoal. So we can't actually read what it says, but for me this is fantastic. This is a 2,000-year-old book, effectively, from an ancient library, preserved because of a volcanic eruption.
And are you curious as to what it could say? Are there any signs at all, and based on its context, where it was of what it might be about?
So I think that's still a work in progress. So Oxford were given 4 sets of these scrolls. There are a few thousand scrolls that were discovered in the library, and some of them are very well-known ancient writings. But as you can see, it's very hard to see what's on them. And so people are having to work very hard to actually work out what the scrolls are about.
So I guess we'll have to visit again sometime in this.
Yes.
Okay, well, let's.
So we're now going to go through and look at something that's rather visually quite spectacular. And these are the volcanic sunsets painted from Chelsea Embankment in November 1883, about 3 months after the eruption of Krakatoa. So Krakatoa was a colossal eruption in the 1880s. People around the world got to know about Krakatoa very quickly because the underwater telegraph networks meant that people were able to send messages describing what was happening. And after this eruption, the most spectacular feature that people could see thousands of miles away from the volcano was the way that after sunset, the skies were lit up with what they called afterglow, tremendously vivid colours. And people worked out at the time that had to be because the light of the sun was catching tiny, tiny particles many kilometres high in the atmosphere. So Krakatoa has transformed our understanding of the way that volcanoes affect the global environment.
So that would have been from ash coming or other particles coming from the volcano?
That's right. In fact, in this case, it's particles of sulfur or sulfate. So the ash particles from the Krakatoa eruption would have fallen out of the sky within a few weeks of the eruption. But these sunsets lasted for around 18 months.
Wow.
So the exhibition's got lots of materials in it. We've got some ephemera. So here we've got film posters from 1950, one set in Stromboli, one set in Volcano. So these are Italian films set about the tales of 2 women, strong women, undergoing under trying circumstances against the backdrop of an erupting volcano. So it's just a snapshot of some of the ways that volcanoes have influenced culture.
Because as we might know, volcanoes are quite a dramatic thing, aren't they?
Yes.
So it's hardly surprising that they've...
So this little object here, I just wanted to give a snapshot of this one because although this exhibition includes something about the science of volcanoes, it's much more about the way that people have come across volcanoes and the effects of volcanoes through time. So this is a diary. This is Mary Shelley's diary. So Mary Godwin, as she was then, had travelled with her friends Lord Byron and Percy Shelley this was the summer of 1816. July, the 24th of July, it's still raining, the weather's miserable, so they can't go out. What they didn't know at the time was that the summer of 1816 was basically the worst summer weather in the Northern Hemisphere on record. And the cause of that, we now know, was a great eruption of a volcano called Tambora, which had happened a year before in Indonesia, 1815. The reason Mary Shelley's diary is interesting is because to make up for the fact that the weather was so poor and they couldn't go out, Byron, Shelley and Mary Godwin decided to have a competition to write a ghost story. And this was where Mary Shelley, she later married Percy Shelley, this is where she wrote Frankenstein. And so a volcanic eruption leads to a tremendous work of science fiction literature.
Indirectly as well. Amazing. Okay, well, let's move on now.
So we're going to move on to one of the cases here, or in this case, we're trying to show some of the objects and materials that modern volcanologists might use to protect themselves, and also for sampling the gas and for measuring the shape and size of the volcano. So in the corner, we've got this fantastic aluminium heat-proof suit. It's really heavy to wear. It's like the thickest, heaviest winter coat you can imagine wearing. And then it's coated in aluminium, and the aluminium reflects the heat away. And because it's a thick winter coat, it means you don't get burnt. So you can actually go right up to a lava flow and collect samples.
Right. So right up to flow.
Right up, pretty close,
okay.
yes.
And is this your own personal suit? Is this one you've worn?
I have worn this suit a few times on Mount Etna, and thousands of children across Oxfordshire have had the chance to wear this at primary school activities or volcano outreach events.
Yeah, and have you found that it does actually do a good job of protecting against the heat? I mean...
Yeah, so basically when you're wearing it, it's like being inside a sauna. So it's hot, but it's not burning hot. And so it does actually mean you can collect samples you wouldn't otherwise be able to collect at the time.
Wow, so you must be still pretty brave anyway, or at least for me, I'm not sure I would.
Okay, so that's just to give an idea of the sorts of things that are in the exhibition. And now we're going to come out through what we call the Transepts. And here we've got about 10 minutes of video footage, which includes the personal stories of people living on St. Vincent who've lived through volcanic eruptions. So this has come out of a project we're involved in called Strengthening Resilience in Volcanic Areas. This is created by my colleagues at the University of East Anglia. And there's some fantastic film footage and personal recollections of volcanic activity. And then we've got some audio of some poems that were written by both school children and poets on Montserrat as a response to a volcanic eruption. So for Saturday afternoon, because it's the end of Science Week, and to go with the exhibition, we have a number of hands-on activities, which are called Hands-on Volcanoes,
Great.
which are out here in the foyer of the Bodleian.
Great, let's go have a look.
Most of these are activities that you can do yourself at home.
Yeah.
And as you can see, it's a crowded exhibit hall. So one activity we've got down on the floor here, we have a map of a volcanic island, and you can see in the top corner there's a little crater, which is the volcanic crater. It's a real map of a real island. And we've given the children some ground rules about where would you choose to put your house. And so we're using this to build kind of the communities living around the volcano over the course of the day. And then we'll think about what the implications were in terms of where they chose to live and what might happen if there was then an eruption following from that. And
does this model the sorts of things you might be talking about or discussing with decision makers on volcanic
Indeed.
islands?
Yes. Yeah, so this activity, we've just left it very simple, and you can see that it's attracting a lot of interest from young children, but this is exactly the same sort of role-playing exercise you could do with people in positions of authority, people in charge of making decisions, people who actually live in those communities, and you can make a more complicated scenario, but you can actually get people to think about what might happen in future scenarios and how you might respond to those.
Because you might think volcano, maybe not, but clearly people do choose to live there. There are benefits.
Exactly. So this particular island, this is the picture here is of the island of St. Vincent in the Caribbean. Tremendous climate, fertile soils. The volcano only erupts every 50 to 100 years, so there are many reasons why you would wish to continue living there. You know, it's your heritage, you've lived there forever. It's just that we can make adaptations to where we live, we can make adaptations to the way that we build roads, where we put hospitals, all sorts of things that will mean that if there is another volcanic eruption, or when there is another volcanic eruption, we've tried to reduce the potential impact of that eruption by thinking about where we put our resources.
Great. Well, I think now we're going to go over here to look at some more activities. So thank you, David. Let's go around here. I think we're speaking to Karen first. Hi, Karen. Hello. Hi. So you've got some interesting things here for us to look at. So do you want to just talk us through what we're looking at?
We're seeing different kind of volcanic rocks here, most of which are the result of lava flows, so molten rivers of rock, just like this one and that one. But we also have this one, which is much lighter, and it's called pumice. And this is here the product of an explosive eruption. So the kind of research that I'm involved in is looking at volcanoes that haven't been studied before, for which we don't really have any accounts of historical activity. And in that case, if we want to have a picture of what a volcano is capable of in case there is a future eruption, we would be looking at the volcanic rocks, look at the chemical composition, the style, whether we see rocks of lava flows or rocks of explosive eruptions. We look at how big these volcanic rock deposits are, and that can tell us something about how often the volcano erupts, how big the eruptions are, what kind of activity we might expect if the volcano wakes up again in the future.
Okay, so we're learning from past volcanic eruptions to sort of tell us more about future ones.
Yeah.
What's this shiny glass-looking thing?
So this is a piece of obsidian, and so that's basically pure volcanic glass.
Oh, wow.
And so if we look at these two together, the chemical composition is almost exactly the same, but this one has erupted like a lava flow, very runny one, that has cooled very quickly and has not had time to form any crystals. Whereas this one, compositionally, is very similar, but it's got a lot of bubbles in it that are the result of gas that has tried to escape. And so this is formed in an explosive eruption. So we sometimes find volcanic products that are compositionally very similar, but because of the gas content in the magma, because that was very different, sometimes it erupts like a lava flow, and sometimes it erupts like an explosive eruption. And of course, that's very important to know for volcanic hazards.
Absolutely. Well, thank you very much for that. I think we're now going to move over here and look at another activity. So let's just go on over here. So this is Tamsin.
Hi there. How are you doing?
You've got some wonderful pictures and models, but can you just tell us a bit about what they are?
Absolutely. So one of the things as volcanologists we want to actually understand is the way that volcanoes change shape. And that's really important for us for trying to understand what's going on underneath. So we've got some models here to kind of show that. So these models are actually both of the same volcano. So this is Mount St. Helens volcano in America. And this is what the volcano looked like here, and this model, before the 1980 eruption. So you can see it's a really classical cone-shaped volcano, very beautiful, with lots of lovely snow coming down off the top as well. Really, really very picturesque. And you can see this in this is a 3D printout, but if we were doing this in a computer, we do it using a digital elevation model. And then the eruption happened, and I'm just going to, somewhere on the table is a picture of the actual eruption. So I'm just going to duck and see if I can grab that.
It's going to be pretty explosive, I imagine. Just take a closer look at this while she's switching out. So there you go. Oh, here we go.
This is what the eruption looked like. So it started on the 18th of May, 1980. So you can see it's an absolutely enormous column of ash and gas punching its way high up into the atmosphere. But actually what happened when Mount St Helens went off is that the side of the mountain here, there was an earthquake and the whole side of the volcano fell in. So the first blast from the eruption was actually what we call a lateral blast, but basically it just went off sideways. So if you see pictures just after the eruption, all the trees are flattened. They look like matchsticks. It's really incredible. All flattened down over here. People who were nearby, unfortunately, did lose their lives, but flattened down here. And this completely altered the shape of the volcano. So this is now a picture of the volcano afterwards. So you can see this sort of amphitheatre shape in the side of the volcano now. This is called little dome that it was made after the eruption happened, and then some gas coming up like that. And here we have a 3D printout of the volcano after the eruption. So if you sort of compare the before and after, you can see that it's blown the whole top of the volcano off, and now you have this amphitheatre scar on the side of the volcano, and then the new dome growing there. And actually understanding the way in which volcanoes change shape helps us to understand whether they're going to erupt, how they erupt, and what the future hazards might be. Because when you change the shape of a volcano, it changes the way that different things flow down from the volcano, and so it changes the hazards from things like mud flows or other associated hazards, or any other type of flow that you might get.
And does it help you also predict then when a sort of active volcano is going to erupt?
Yeah, so with Mount St Helens, what they did see was they saw this whole side of the volcano swelling up. Because there'd never been a lateral eruption beforehand, they didn't really know what it meant. But this sort of, it was like a blister, if you like, on the side of the volcano. And the really exciting thing we can do now is we don't actually need to be on the ground with GPS, global positioning systems, or with making measurements or anything like that. We don't need to be on the ground anymore. We can do it from satellites. So we have these really clever satellites based on radar, and they send radar beams down from space to the surface of the Earth, and then they come back a few days later and send it down again, and they can tell whether there's a difference, whether the land has moved towards the satellite or away from the satellite. We can use that to tell us whether the volcano is swelling up or subsiding. So here you'd have seen a pattern of swelling up on the side of the volcano, and we're getting better and better at understanding what that means in terms of whether there's going to be an eruption or not. And I think if you go over there, you're going to learn some more about satellites over there.
Well, thank you very much for that. Let's go look at some satellites. So I just need to worm my way through here. Excuse me. Thank you. Chris. Hi there.
Hello.
Hello. So we've just been speaking about looking at how volcanoes change shape using satellites, and I believe you have one for us to see.
Yeah. So part of what we're doing here today, so I'm from an organisation called the Satellite Applications Catapult. And part of what we're trying to do is to make space more accessible for businesses and for perhaps countries and organisations that haven't had the chance to do that before. So we actually have a small satellite here. So this is actually a working satellite. It's called a pocket sat, and it is about 5 centimetres cubed, with a small camera on the front there for taking imagery of the Earth. And also you can notice there's some solar panels and things on the outside as well, and some antennae and things for talking to the Earth. So we normally will send up about sort of 20 or 30 of these satellites to replace one larger satellite. So rather than having a single purpose satellite for one single mission, we can actually have multiple satellites orbiting around in a cluster to try and solve multiple different societal issues. In particular, looking at volcanoes and imagery from volcanoes, we can actually see things like the shift in the Earth. So actually trying to see if we can find different ways of using technology to predict earthquakes before they happen, and volcanic activity as well.
And so is the benefit of something that's this small over something that's bigger and more complicated that it's cheaper, or?
Yes, very much so, yeah. So when we're so the cost of launching something into space is still quite high. So we still have to use rockets and sending stuff into orbit. So what we've tried to do is see if we can change the way in which we build satellites to essentially make it much cheaper. So that, again, it's more accessible. So this sort of satellite is around about between sort of £5,000 and £30,000, whereas a traditional satellite you're looking sort of several £100,000s. And that's not including the launch. So actually, to build them much cheaply, to use technology that's sort of over the counter, you can actually make space more accessible for everyone.
And I think you had an image of it's probably got lost in.
So the types of imagery that we can take, we can take from space really does depend on the type of sort of technology and things. So this is actually an image taken, multiple images taken over a single, multiple orbits, excuse me, and this is of Mount Etna. And what we can actually measure is the change in the Earth based on centimeters per month, so we can actually see the change over time. So we can start. So they've actually sunk down, yeah. So what that could indicate is there's actually potentially a magma chamber there or something underneath the surface that could actually then tell us actually there's more of a likelihood that the volcano may erupt in the future. So again, it's just using information and data in a way that can help potentially save lives or indeed actually change the way in which we can view our planet.
And do you know how long it takes for us to sort of get these images and process them and things like that? I mean, can they be used in a sensible period of time that they can give us sort of early warning and things like that?
So that's something that we're working on at the moment. So we are, with the technology at the moment, we can't quite get sort of real-time imagery and then make that accessible on the ground. That's something that we are working on though at the moment, and that's what part of our organisation does, and also we work with researchers and scientists all over the world because this is something they're looking for. So ultimately the long-term goal is for someone to have an application on their phone that will be able to tell them what's happening with the volcano right next to them, but using the satellite data above them. So that's something that we're a little bit not quite there yet, but that's something that we're desperately working on.
Great. Well, Thank you very much, Chris. So here we've seen them. We've got volcanoes past, present, and hopefully the future. But also you can have volcanoes in your home. So we've put a link up on the Facebook Live page for make your own cutout paper volcano. That we can see that lots of the kids have been making their own just there. So did we have any questions? No, oh, okay. Well, thank you very much for watching then. I'll say thank you on behalf of David, Tamsin, and Karen and Chris. Thank you very much for joining us on this Facebook Live. If you haven't seen all the other ones we've done sleep, we've done neurosurgery, we've done driverless cars, all sorts of different things. Check it out on our website, Google Oxford Sparks. And yeah, thanks, and we'll see you again next time.